Hey there, Full Context Agent here, and in this video we will talk about the main keyword in the channel's name, AI agents. Now, you might have heard a lot about AI agents, or not much at all. But the thing is, AI agents are here to stay, and the more we know about them, the better equipped we are to take advantage of them, both professionally and personally. There's a lot happening in this space, and it's easy to feel overwhelmed, especially with daily developments that are taking place at breakneck speed. So instead, we will try to take a step back in this video and look at the big picture. By the way, you don't need to be a software developer to follow along, as I will try to explain things as we go. So without further ado, let's get started. So what is an AI agent exactly? Simply put, an AI agent is a computer program that has agency. Like, wow, nobody thought about that. Anyways, meaning it can make nonlinear decisions without being explicitly told so. That is, we don't have to give specific instructions on how to solve a given problem to the AI agent. We'll get back to this concept of determinism and linearity a little bit later, but suffice to say that an agent has full autonomy to decide how to solve the problem that it was designed to solve. To give some examples, today we have coding agents, which are quite popular. We have also general purpose agents like Manus, or we have agents specialized in more specific tasks like booking trips, refunding customers, or scheduling meetings. But then, how are these agents different from regular software? As I said earlier, it all comes down to determinism, or lack thereof. In traditional software, developers predefine every step or every possible execution path beforehand. Sure, like we have if statements, loops, and switches to handle different scenarios, but at the end of the day, the flow of the logic is predetermined the moment we compile or interpret the program. Agents work differently in the sense that we give them access to tools through MCP, which we covered in the previous video, and if you're not familiar with that, you can watch that one. They also have access to large language models, which serve as the foundation that gives them reasoning capabilities. And so, when you give an agent a task, it dynamically decides which tools to use and how many times to use them based on the specific situation. So if I ask an agent to book a trip, it might make 3 API calls to flight booking services, or maybe 7, or maybe it discovers it needs to check visa requirements first. The execution path isn't predetermined, it emerges from the agent's reasoning process. Let's take a look at this diagram of how agents work compared to traditional software. Now, if I can find a diagram, that would be nice. Okay, so in this diagram, we have traditional software on the left and AI agents on the right. In traditional software, it's quite obvious that it's a linear execution path. So the logic is predefined, it runs the same way every time, and it outputs the same output every time. AI agents, on the other hand, they use LLMs to reason, and they come up with dynamic decisions, mainly decisions of which tools to use. And based on the result of calling these tools, they decide if they need more actions or if the task is complete. If the task is complete, then they're basically done. But if it's not, they go back to the reasoning step and make more dynamic decisions. And this loop could be running once or twice or 100 times. And there's no way for us to know beforehand how many times it will run or which tools will be called every time we give it a task. So now that we know what agents are, let's talk a little bit about how to use them. Obviously, for personal use, anything goes. But in a professional setting, there are some good rules of thumb to follow. In particular, the one that is most important is that AI agents are suited for workflows that have previously resisted automation. That is to say, stuff that traditional software couldn't handle effectively. Usually, these are tasks that require complex decision making, difficult to maintain rules, or rely on unstructured data. We will look at each in detail as we follow along this diagram. So let's say we have a given automation problem and we want to evaluate if agents are a suitable solution. First, we ask ourselves if the task requires complex decision making. Think about something like refund approval in customer service, where traditional software systems worked like a checklist and flagged transactions based on preset criteria. In contrast, an AI agent functions more like a seasoned investigator and evaluates context while considering subtle patterns and trying to identify issues even when clear-cut rules aren't violated. For example, maybe a customer's refund request technically meets all the criteria, but there is something about their purchase history or the way they're describing the issue that suggests fraud. A rule-based system would just approve it, but an agent can pick up on those nuances. If we're dealing with a problem where the decision-making isn't complex, then we move on to the next decision criteria: difficult to maintain rules. You know, systems that have become absolutely unmanageable because of extensive, intricate rule sets, where making any change feels like you might break something else. We have all dealt with those, and we can agree they kind of suck. Take, for instance, vendor security reviews. You might have hundreds of criteria, exceptions to the criteria, and exceptions to the exceptions. Instead of trying to encode all that logic, an AI agent can reason through each case based on the underlying principles, making it a perfect fit for these kind of problems. As a side note, the difference between the first and second criteria is that the first focuses on nuanced decision making that involves multiple parameters, whereas the second is more about the number of nested rules that make up the branching paths. Now, if both of these are answered with a no, the last criteria we need to look at is if the tasks rely on unstructured data. Anything involving natural language interpretation, extracting meaning from documents, or conversational interactions is traditionally very hard to automate. For instance, processing insurance claims, where you've got photos, written descriptions, policy documents, previous claims history, all kinds of messy, unstructured information that needs to be synthesized into a decision. Agents excel at these kind of tasks, especially if they're backed by multimodal LLMs, foundational models that work with text, images, audio, and so forth. Now, if the task doesn't rely on unstructured data, then it's a good candidate to be solved using traditional software. Examples include linear workflows, repetitive tasks, or structured data processing. As for these, a simple deterministic solution will be faster, more reliable, and easier to maintain. The common thread here is that agents excel where you need a combination of reasoning, logic, and access to external information. They're particularly good at open-ended problems where the number of steps is unpredictable and you can't hard-code a fixed path. At the same time, they are not a one-size-fits-all, and they can clearly be counterproductive when used for the wrong type of problems. Before we wrap up this video, I'd like to touch on another aspect of AI agents, especially for those interested in building them, and that is specialized versus general purpose agents. Is that we can be easily tempted to build a super agent that does everything, but that is not the way to go, especially if you have specific problem you're trying to solve using AI agents. The reason is agents with too many responsibilities take longer to complete tasks, and often produce lower quality outputs. It's basically like asking one person to be a lawyer, a doctor, and a chef simultaneously. Sure, they might be capable, but they won't be as effective as specialists in each of these areas. Specialized agents, on the other hand, will have a limited set of tools to work with and a more focused system prompt, which will lead in less probability of them getting stuck in an infinite loop, or what is usually called the Halton problem in computer science, and it will also result in much better outcome at the end of the day. So let's say we have a complex task, let's say conducting a survey. If we use one super agent, it will most likely result in a slower performance and lower quality, whereas specialized agents, like let's say an HR agent, an email agent, and a parser agent, will do a better job together than a single agent. We have reached the end of the video. I hope you liked it, and if you did, please poke that like button and subscribe so that I can make more videos like this. Thank you for watching, and catch you in the next one.